I was assigned the protein melanocortin 1 receptor, and the mutation was arginine number 67 is replaced with cytosine. Usually, melanocortin 1 receptor provides instructions for the fur color of mammals. It is a receptor because it binds to a melanocyte stimulating hormone to carry out its function. MC1R is usually found in the plasma membrane of specialized cells and melanocytes, which are usually found in mammals. When MC1R is mutated, the protein becomes less active. It's actually non-functional. They stop binding to the melanocyte stimulating hormone, which makes mice specifically lighter in color. The main functional group present in the original AA side chain is a hydroxyl group. It's hydrophilic, which means it's polar. It's negatively charged. And in relation to the 19 standard functional groups, it's pretty small. With the mutation, it still has a hydroxyl group at the end. Specifically, it's carboxylic acid. It's still hydrophilic, which means it's still polar, it's still negatively charged, and it's still pretty small in comparison to the rest of them. The difference is just that with the mutation, the protein becomes non-functional, meaning it doesn't bind with the melanocyte stimulating hormones and doesn't produce the dark color commonly found in the mouse fur, which makes it harder for them to hide from their predators unless they're in areas like the beach with surrounding sand that's closer to the color of their fur. So for my model, I have two different cups. Cup A represents the normal melanocortin 1 receptor, and B represents the one with the mutation. A has water in it, and B has isopropyl alcohol in it. This nail polish will represent the melanocyte stimulating hormone. So in A, we'll be able to see that when the color is dropped in there, it spreads. And then when the color is dropped into cup B with the mutation, it falls to the bottom and kind of just separates. It doesn't do what it's supposed to. This represents how, with the mutation, the protein itself isn't functional. It doesn't do what it's supposed to do. With the normal one, you can tell that the red has spread, and that's what creates the color. The limitations of my model are that you can't specifically see the mutation because the water and the alcohol, isopropyl alcohol, look the same in the cups. You can only see the difference when the color is dropped in. One spreads out like it's supposed to, and one just drops to the bottom and doesn't really do anything, which shows how the protein becomes non-functional with the mutation.